Hello students, we are here to study tool workpiece thermocouple method. Now what is this method? This is a method to know the average temperature during the metal cutting. Tool and work materials are dissimilar and the temperature in the cutting zone is higher than the rest of the tool or work. Hence the tool work contact serves as the hot junction is the thermoelectric circuit and EMF generated is proportional to the temperature. A typical setup as shown, I will be showing you in this figure. If we consider this as a tool and a heating coil is inserted near the tool, where the tool is inserted, this will act as a tool and this crater is filled with lead bath. Here a heating coil is given to heat this crater. This is a lead bath and this rod acts as a tool, and this is a chip. If we consider this rod as a tool and this chip, it will act as a thermocouple and it is attached with the recordings. This is a copper wire. Here one more thermocouple is also inserted, which is attached with a potentiometer. The end of the tool is ground. Here the end of the tool is ground nearly about 3 mm in diameter and a long chip generated by machining with a very light feed is made as a tool work thermocouple. A mercury slip ring connection at the end of the workpiece through the spindle bore is convenient way for completing the EMF circuit. These are also having some errors as not an ideal thermocouple. This is not an ideal thermocouple, so the EMF is very low and the calibration need is always be a straight line. It will not be the straight line as it is not an ideal thermocouple. Doubt in the calibration can also be there as this procedure because it is done in a stationary situation. In actual metal cutting, the workpiece is rotating and the tool is feeded, but here it is not a actual method to know, so here we can only find the average temperature. It is possible only to find average chip tool interface temperature from the above experiment. However, it is possible to use analytical techniques for predicting the average temperature as well. The source of major heat in the metal cutting being located at the tool tip. Here tool tip is the source of major heat. The temperature there would be the highest. The temperature then would conduct the tool, work and chip. The temperature here will be conducting to the tool, work and the chip. The tool is one which accumulates most of the heat while chip and the work surface in contact with the tool are continuously changing. The temperature always are changing in the workpiece, in the chip, but the actual highest temperature is in the tool tip. Thus the temperature on the tool should be the highest. This only calculate or calibrate the average chip tool temperature. The setup measuring average chip tool interface temperature using chip tool thermocouple. Thank you.